We're now looking at number 5. We're looking at A, and A says, suppose one person told you that the solution to 45 equals 98 minus 0.54t is t equals 100, and another person told you that the solution is t equals 98. How could you check to see if either one is correct without using a table or a graph? So we've been using tables, we've been using graphs, that's all we were allowed to use. Now we're looking at other ways to figure out if an answer is correct or not, or to discover an answer. So we're going to use our equation. What I did is I wrote out the equation twice, and I put above the left side t equals 100, which was one solution we were given, and above the right side I put t equals 98. What I'm going to do is I'm going to plug in t equals 100 in blue, and then I'm going to go ahead and solve the equation. So 45 equals 98 minus 54. So we get 45 equals 44. Now that's not true. 45 is not equal to 44, but 44 is pretty close to 45, so we would call this an approximate solution. It's not exact. That's what we've been doing a lot in this investigation is we'll look and we'll estimate. Let's come over here to the other side where we have t equals 98, and I'm going to plug in 98 here. 98 multiplied by 0.54 gives us 52.92. Then I take the 98 and I subtract the 52.92 and I get 45.08. Once again, these are not equal, so this is also an approximate solution. It would be an exact solution if you plugged it in and you got 45 is equal to 45. So these are both approximate solutions. We addressed B by talking about approximate and exact solutions. Now we're going to address C. So letter C says, if a solution for an equation is exact, does that mean that the answer to the prediction question is certain to be true? Explain. And what I'd like to do is I'd like to go back to the book and take a look at one of the questions. For example, 4A, when will the percent of male doctors decline to 55%? When we use our prediction line, if we get the exact year that it is predicted that the male doctors will be at 55%, that doesn't mean that that is what is going to happen. It's a prediction. We don't know for sure what's going to happen. We're making an estimate. We're making an educated guess about what is going to happen. So no, even if you get an exact solution, that's not certain to be what happens. Let's go ahead and look at number 6. If someone told you that the solution to 2 plus 0.54t is less than or equal to 45 is t is less than or equal to 80, how could you check the proposed solution, A, using a table? So let's just start with a table. So we're looking for where the percentage of female doctors, so Y2, is less than or equal to 45. And we're being told that that is going to occur at where t is less than or equal to 80. So what we're going to do is we're going to look at the female doctor equation in the calculator, and we're going to look at specifically the year, well, 80 years, and we're going to see if this is true. So I'm just going to look at the female doctor data, and then we're going to look at, in our table settings, we're going to go directly to x of 80 or t of 80, and in our table we're looking at where the number of years is less than, and I believe equal to 80. Let's look back really quick. Yeah, so t could be equal to 80 or it could be less than 80. So that would include like 79 and 70 and 60 and 54 and all of those lower values. And we're going to see if the percentage of female doctors is equal to or less than 45. Okay, so it is equal to, well, for 79 years, it's equal to or less than that 45. But at 80 years, you can see that it's actually, at 80 years, the percentage is above 45%. So the solution they gave us here is another approximate solution. It's not exactly, 80 years is not exactly where we're at 45%. But it is true that when they said t is less than 80, that was the correct inequality, because when the years is less than 80, you can see that the percentage of female doctors is definitely below the 45%. If we would have said instead t is greater than or equal to 80, if you look at the table, you can see that at 81 years, the percentage is greater than 45. If you go scroll all the way down to where T is 88, again, the percentage of female doctors is over 45%. So it is correct that the inequality should be facing the way it is. So T is less than or equal to 80 is an approximate solution. It's pretty good, fairly good solution. So how can we tell that from the graph? So let's go straight to the graph. And first of all, we're looking for just where t is equal to 80. So I'm going to press trace, and I'm going to look for where t is equal to 80, and I'm going to have to scroll down the graph. Oh, and I just passed it. So when you look at the graph, you can see that around 80, the percentage is about 45, and when t is less than 80, so I'm scrolling to the left, you can see that the percentage is much under 45%. So that inequality makes sense. It's harder to tell with the graph if 80 was the exact solution, t is less than or equal to 80. If you want to try to get it to be closer to 80, I mean, this is pretty close right now. It's showing on my calculator, being able to get to 80.1. But if you want to try to get closer, you could go to zoom and choose number 3, and I could zoom in on that spot, and I'm going to zoom in twice, and then I'll press trace again. And I don't know if I'm able to get any closer than what I was. Let's see. Oops, and I pressed zoom out, not zoom in. Let me try that again. So zoom in, I'm going to zoom in, and then I'll zoom in again. And then I'm going to press trace. And it doesn't look like I'm able to get closer, but you might be able to on your calculators if you were zoomed out pretty far. For example, if you could only see 80.7 and 79.7, you would be able to zoom in a little bit closer to that value of 80. So now the last thing we need to do is we're going to look at if you would use an equation. So D says without using a table, a graph, or a computer algebra system. And of course, we're skipping the computer algebra system. We don't have the computer algebra system. So letter D, we have to use an equation, or an inequality in this case. So what I'm going to do is I'm going to pull up the Smart Notebook, and we're going to write our equation. 2 plus 0.54t needs to be, I think it was less than or equal to 45. Let me check back. Less than or equal to 45, good. And the solution was t is less than or equal to 80. So the first step is to take simply the 80 and replace this symbol with an equal sign. So we're just focusing on this portion right here, the equal to 45. If it was an exact solution and you plugged in the 80, then 45 at the end will be equal to 45. So let's go ahead and multiply 0.54 times 80. And we get 45.2 equals 45. So it's not an exact solution, but it's fairly close. From here, what we're going to do is we're going to look at the region where t is less than or equal to 80. To check that region, what I'm going to do is I'm going to choose a number that is pretty far below 80. So I'm going to go 10 under. The reason why I go, not to 79, but all the way down to 70 is because, if this isn't an exact solution, then maybe 79 was, and I'm not really checking the inequality if I'm not far enough from the 80. So I choose 70, and I'm going to plug that in and see if this still holds true. 2 plus 0.54t, and in this case, I'm focusing on the area where it should be less than 45. So we'll highlight this part in blue. I'm looking at the blue part when I complete this inequality. So I plug in, not 80, I plug in 70. And I take the 0.54 times the 70, and I get 37.8. And you can see that 39.8 is less than 45. So that less than or equal to was the correct direction for the inequality. Let me just prove that it would work for checking if you had the incorrect answer. For example, let's say that they told us that the solution was t is greater than or equal to 80. If it was greater than or equal to 80, I would complete this first part like I just did before. And then I would choose a number from the solution set t is greater than or equal to 80, such as 90. Again, you want to have some distance between your solution of 80 and then the extra solution you use to check out the inequality area. So now I'm going to plug in, instead of 70, I'm going to plug in 90. And that should be, again, less than 45. So 90 times 0.54, I get 48.6. So 50.6, well, that's not less than 45. So that would determine that this is not correct. The 80 was a pretty good approximate solution, but the inequality should be facing the way that they gave it to us. So that's how you check an inequality. And let's look back. I think that's everything for number 6. Okay, it also says, letter E, if you wanted to see if a solution is exact, which method of checking would you use? And really, that's an opinion question. I would prefer the algebraic method when we use the equation. But yeah, you could get pretty close when you're looking at the table and the graph.